we just that we have, yeah, we have an object whose variant is equal to the variant of the light. Then the light will bend around that object, right? Is what we asked. And then we talk about kind of direction, but before we do, let me also discuss this one thing, right? So let's say, why? Yeah, so yep. So say let's say have so you are flashing a light on some object, right? So this example is also very crucial. So let's say you are flashing light on an object, right? Yeah, I know I didn't. Okay, so let's say you have this object, right? We have this object, and if we flash the light from here, right? Then on this part, what we will see? From here to here, what we will see? If we are flashing the light on this object, right? Let's say you have, let's say you have this screen, and on this screen, in front of this screen, you have put this object, and then you flash some light from here. Then in this region, what you will see? What you will see, guys? Yes. Okay, so let us take the example of sun, right? You have a sun, and then some building is in front of the sun. So behind the building, what you will see? Yes. Did you understand the question? What is a shadow, guys? What is shadow? Yes. So if you flash a light on something in the back of the side, you will see the shadow of that object, right? Right,
Yes, sir.
guys?
Yes,
In
sir.
here you will see shadow. In here you will see the shadow of this object, right? But diffraction is a very interesting number, right? Let's say, can you see some white light on this shadow? Can you see that? You cannot, right?
Right.
Light always
Yes, sir.
travel in the space bar, so you will only, yeah, you will only see the shadow of this object. But if the object is within the edge, right? So in here, let's say you have this blade, right? You have this blade, whose edge is very small, right? So it can cut your finger. So yeah, the edge of the blade is very, very small, right? So from that edge, this light will go and then it will bend. So it is quite interesting that on this shadow you will see some light, right? And that light is coming due to this diffraction, right? Because from the reflection and refraction you cannot see this object, but from this diffraction will penetrate this shadow. So that is the property of diffraction, right? So that part, yeah, we didn't do in the previous class. So that is another definition of diffraction, right? It can penetrate the shadow. So that is diffraction when this size of this object is comparable to the wavelength which are income, right? And in the previous class, we understood about, okay, before we talk about this thing, right? So did you guys note down this part? In the previous class, did you guys note down this part? I guess you guys have noted, right? So then we were talking about two kinds of diffraction. One was this Fresnel diffraction, right? So these two kinds of diffraction are defined on the basis of the separation of source and the slits, right? So that is what we call Fresnel and Fraunhofer diffraction on the basis of separation between the source and the slits. So let's say,
Excuse me, sir.
yes, yes, boss, yes.
No, yes, sir. Last class I didn't know that. Last class I noted this right, the energy stored in the capacitor and other stuff like that. I didn't know.
So this is another class, Aslan. This is wave optics. So go back to the previous two classes, not the backup class, right? That you and me are doing. So not that class. This is diffraction.
Yes, sir.
Yes,
Wait one
that
second.
this
One
class,
second.
this class we are doing with Aisha and Maryam, right? So this is a different class. Capacitance, yeah, we are doing capacitance with you and me because Aisha and Maryam, they have already done chapters. So they
Yes,
have
sir.
done these chapters, they have already finished. So yeah, capacitance, not the capacitance. Yeah, let's move back to the second book, reflection. So this part we have noted, right? When we were talking about that why we usually don't see diffraction in our daily life, but the diffraction of sound we see in our daily life, that we see. But we don't see the diffraction of light in our daily life, right? So that part we did in the previous class.
Yes, sir.
Okay. Yeah. So I guess you have noted that part, right? Or did you get disconnected some? I guess you got disconnected. Yeah. So we were talking about the definition of these two kinds of diffraction. So if source, this is the source, right? If this is the source and this is this slit, right? So the if the separation between them is infinity, not finite, right? Let me call it as not finite. Then, okay, so not finite is the other case. So if this is finite, right? If this is finite, then it is called Fresnel deflection. So when the separation between the source and slit is finite, right? Then it is called Fresnel. And when you guys will go to graduation, right? So then you guys will do all these practicals. These are very beautiful practicals. So you see those parallel diffraction pattern and those interference pattern. Those are very quite nice. So Fresnel diffraction. And then if you have a source, right, and then a slit, and the separation between the source and slit is infinite, right? So, and let me check if you guys remember or not. So when the separation between the source, देखना जरा, between the source and slit is infinite, right? Then that kind of then it is called Fraunhofer Fraunhofer diffraction. Right now, I will ask you guys that. Okay, so now I will ask you guys that how do we show the infinite wavefront? So if the source is at infinite, so what kind of wavefront is this? One moment, guys. My Wi-Fi provider has come. So let me talk to you. Okay, one. Give me 5 minutes. Can you guys give me 5 minutes? I will be back in a moment. Can I go for 5 minutes, guys? Yes.
Okay, sir.
Okay. Yeah, yeah. Give me five. One. Yes, guys, my Wi-Fi is configuring. Yeah, sorry for this glitch, but yeah, I'm coming. I'm coming. Yes, guys, it is taking so much of time. So, uh, okay, so it is called from reflection. So, what is when the source is placed at infinity? So, how do we show the wavefront? What is the wavefront, guys? Yes, are you guys there?
Yes, sir.
Yeah, so, what is the wavefront if the source is at infinity? Sorry about Yes, guys. Yes. Hello, everyone. Can you guys hear
Yes,
me?
sir.
Yeah. So on what about this Saturday? Because it is taking time. So what about this Saturday or Sunday? Are you guys free on that day? Any one of these days? Are you guys free?
So
Ye-
Saturday I
Sir,
have
Okay. So Saturday.
gigs.
So Saturday is
So when are
cancelled. Then
you?
what about Sunday? Sunday, let's say 5 p.m. My 5 p.m. would be 2:30 p.m. of so 2:30 p.m. KSA. What about that?
sir, I come
Yes,
home from school at
is
2:30
it okay?
p.m.
Oh, okay. That Sunday is fine. Cool. Then what about 3 p.m.? 3 p.m. KSA. What about that? Which is 5:30. What about
Yeah,
3 p.m.? Is it okay with everybody?